With your remote backend set up and configured, it's time to implement a continuous integration and continuous deployment pipeline using GitHub Actions. This will automate the deployment process of your static website to AWS using Terraform. While there are several tools available like AWS Code Pipeline or Jenkins, in this demo, you will utilize GitHub Actions due to its advantages. GitHub Actions offers free minutes for public repositories and provides a generous allowance even for private repositories, making it cost-effective. It is natively integrated into the GitHub platform. This means you can set up CI/CD workflows directly from your repository without the need for third-party integrations. It also streamlines configuration processes using YAML files directly in your repository. In this demo, you will create a GitHub Actions workflow that will streamline and speed up the deployment process, and also eliminate manual errors, ensuring consistent deployments that allow for faster feedback loops. You will create a workflow that will be triggered by a Git push, and it will automate various steps, ensuring your infrastructure is consistent and up to date. Before setting up the CI/CD workflow, you'll need to establish the right directory structure in your repository. Within the root directory of your repository, you'll create the GitHub folder and subsequently the workflows subdirectory. Creating the GitHub folder is important for the following reasons. GitHub natively recognizes the GitHub folder and knows to look within it for specific workflow files. This standardization allows for more organized and efficient repository management. Within the GitHub directory, the Workflows subdirectory specifically holds workflow configuration files for GitHub Actions. Placing CI/CD workflows here ensures they're automatically detected and run by GitHub Actions based on your defined triggers. The GitHub directory organizes your repository by centralizing GitHub-specific configurations and templates, like workflows and issue templates. This keeps GitHub configurations separate from your main codebase, ensuring a tidy repository structure. To begin, open the terminal, and confirm you are within the root directory of your GitHub repository. You can do this by running the pwd command. Now create the required directories, using the mkdir command. In the terminal enter mkdir -p GitHub /workflows. This command creates both the GitHub folder and the workflows subfolder inside it. Next, create a workflow file. Navigate into the workflows folder using the cd command. Within the Workflows directory, create a new file with a descriptive name, using the touch command. In the terminal enter touch, deploy, -website, YAML. Open the empty workflow file. To begin with, you need to ensure that GitHub Actions has the necessary permissions to interact with your AWS account. You must provide the AWS Access Key ID and Secret Access Key as environment variables. These credentials authenticate and authorize the GitHub Actions workflow, granting it permission to deploy infrastructure on your AWS account. By storing these values as GitHub secrets, and referencing them as environment variables in your workflow file, you ensure the credentials are securely stored and not exposed in your code, while still being available to the GitHub Actions runner during workflow execution. Before proceeding, you need to create access and secret access keys for your IAM user. To do so, you can utilize the AWS CLI command. In case you've forgotten your IAM username, you can run the Terraform output command, as this output was referenced in part 2. Using the cd command, navigate to the Terraform folder. And then enter Terraform output. Next, execute the AWS CLI command to create a new access key for the Terraform user. In the terminal, enter AWS IAM create -access -key. /user -name. Terraform _user. Make sure to securely store the secret access key, as it won't be accessible post-creation. Now navigate to your GitHub repository, and open the Settings tab located near the top right corner of the repositories page. In the left navigation pane of the Settings page, choose Secrets and Variables. Choose Actions. Click the New Repository Secret button. First add the AWS Access Key ID. For name, type AWS _access _key _ID. For secret, enter the actual AWS Access Key ID. Click on Add Secret. Click the New Repository Secret button again to add the secret access key. For name, type AWS _secret _access _key. For secret, enter the actual AWS secret access key. Click the Add Secret button. GitHub secrets are now securely stored and associated with your repository. These secrets can be accessed within your GitHub Actions workflows. Now, let's begin by writing the workflow. Close the terminal to create more space. On line 1, specify the name of the workflow. This is used for display purposes in the GitHub Actions UI. Type name, deploy website. On line 3, define the trigger for the workflow. In this case, you want the workflow to run on push events to the main branch. Type on, and press enter. Type 2 spaces, then push, and press enter. Type 2 spaces, then branches, and press enter. Type 2 spaces, then -main. Next, you will define a job named Terraform. Press enter and proceed to line 8. Press the backspace key 3 times until the cursor is in line with on. Now type jobs, and press enter. Type 2 spaces, then Terraform, and press enter. Next, specify the name of the job. Type 2 spaces, then name, and deploy, infrastructure. Now, specify the runner for the job. A runner is required to define the environment in which your GitHub Actions job will run. It ensures the necessary tools and software are available for your workflow. Press enter and type, runs, -on, Ubuntu, -latest. Ubuntu Latest is a popular choice because it provides a modern and well-supported Linux environment, suitable for a wide range of workflows. Move down to line 13. You will now define environment variables. Type env, and press enter. First you will reference the AWS access key ID that you stored as a GitHub secret. Type 2 spaces, then in capitals, AWS _access _key _ID space. $ curly brace space secrets period. In capitals AWS _access _key _ID space. Next, reference the AWS secret access key that you stored as a GitHub secret. On line 15 in capitals type AWS _secret _access _key space. $ curly brace space secrets period. In capitals AWS _secret _access _key space. Your current Terraform configuration requires input variables to create and manage your infrastructure on AWS. Currently they include the region, the name of the IAM user, the name of the S3 bucket, and the name of the DynamoDB table. Your workflow will require these variables to successfully execute the Terraform scripts that define your infrastructure. These variables are currently defined in your terraform.tf file. However, as you recall, they are included in your gitignore file to prevent it from being committed to your repository. This approach keeps sensitive information secure, but it also means that the variables won't be available in your workflow, because the terraform.tf file isn't in the repository. You could simply remove the terraform.tf file from the gitignore file. Or as a better approach, you can use GitHub Secrets to store these variables. By defining these variables as secrets in GitHub, you can securely pass them to your GitHub Actions workflow as environment variables. This ensures that your sensitive information remains secure, while also being available for use in your workflow. Return to your GitHub repository, and create a new repository secret. First add the region variable. For name, in capitals type TF, _var, _region. For secret, enter US, -east, -1. Click on Add Secret. Click the New Repository Secret button again to add the IAM username. For name in capitals type TF, _var, IAM, user, name. For secret, enter Terraform, user. Click the Add Secret button. Click the New Repository Secret button again to add the bucket name. For name in capitals type TF, underscore, var, underscore, bucket, underscore, name. For secret, enter your bucket name. Remember, you can find these values in your terraform.tf vars file. Click the Add Secret button. Click the New Repository Secret button again to add the table name. For name in capitals, type tf, underscore, var, underscore, table, underscore, name. For secret, enter Terraform, underscore, state, underscore, locks. Click the Add Secret button. These secrets can now be accessed within your GitHub Actions workflows. In Terraform, you can define variables to parameterize your configuration. To set a value for a Terraform variable using an environment variable, you prefix the variable name with tf-var. In GitHub Actions, you can map GitHub secrets to environment variables to securely pass values to your Terraform variables. Terraform will then use these values when run in the workflow. Please note that the variable names should be consistent in both the Terraform code and the GitHub Actions workflow file. To start, map the value of the tf-var region secret to the tf-var region environment variable. Proceed to line 16, and type tf underscore var, underscore, region, space. $, curly brace, space, secrets, period. tf, underscore, var, underscore, region, space. Next, map the value of the tf-var IAM username secret to the tf-var IAM username environment variable. Proceed to line 17, and type tf underscore var, underscore, IAM, underscore, user, underscore, name, space. $, curly brace, space, secrets, period. tf underscore, var, underscore, IAM, underscore, user, underscore, name, space. Next, map the value of the tf-var bucket name secret to the tf-var bucket name environment variable. On line 18 type tf underscore var, underscore, bucket, underscore, name, space. $, curly brace, space, secrets, period. tf underscore, var, underscore, bucket, underscore, name, space. And finally, map the value of the tf-var table name secret to the tf-var table name environment variable. On line 19 type tf underscore var, underscore, table, underscore, name, space. $, curly brace, space, secrets, period. tf underscore, var, underscore, table, underscore, name, space. The environment variables will now be used by Terraform during the init, plan, and apply steps to configure and deploy your infrastructure. Moving on, you will set the default working directory for the steps in the workflow. You will set the default working directory to the Terraform directory, meaning that all steps in the workflow will be executed in that directory, which is where your Terraform configuration files are located. Now proceed to line 21, and press the backspace key once, ensuring the cursor is in line with env. Type defaults, : and press enter. Type 2 spaces, then run, : and press enter. Type 2 spaces, working dash directory, : then space, period / Terraform. This sets the default working directory for all run steps in the workflow to the Terraform directory. By using defaults, you can simplify your workflow file and make it more readable, as you don't need to specify the working directory for each individual step. Next, you will define the steps of the job. First, add the step to check out the repo. Proceed to line 25, and press the backspace key 2 times, ensuring the cursor is in line with defaults. Now, type steps, : and press enter. Type 2 spaces, space, name, : space, checkout repo. Then press enter. Type 2 spaces, uses : space, actions, / checkout at v2. This action checks out your repository onto the runner, allowing your workflow to access its content. Next, add the step to set up Terraform. Proceed to line 29, press the backspace key once, type space, name, space, Terraform setup. Then press enter. Type 2 spaces, uses : space, HashiCorp, / setup Terraform, at v1. This action installs a specific version of Terraform on the runner and configures it for use. It's like setting up Terraform on a new machine. Next, add the step to format the Terraform code. Proceed to line 32, press the backspace key once, then type space, name, space, Terraform format. Press enter, type 2 spaces, run : space, Terraform, FMT. This command automatically updates Terraform code in the directory to conform to a canonical format and style guidelines. This step ensures that the code is cleanly formatted. Next, add the step to initialize the Terraform working directory. Proceed to line 35, press the backspace key once, then type space, name, space, Terraform init. Press enter, type 2 spaces, run : space, Terraform, init. This command initializes a new or existing Terraform configuration by installing any necessary providers and setting up the backend, where Terraform state information is stored. Next, add the step to validate the Terraform configuration files. Proceed to line 38, press the backspace key once, then type space, name, space, Terraform validate. Press enter, type 2 spaces, run : space, Terraform, validate. This command initializes a new or existing Terraform configuration by installing any necessary providers and setting up the backend, where Terraform state information is stored. Next, add the step to create an execution plan. Proceed to line 41, press the backspace key once, then type --name: Terraform plan. Press enter, type 2 spaces, run : Terraform plan. Whilst Terraform apply can do the work of plan and apply together, splitting them into separate steps gives you more control, visibility, and safety in your deployment process. If there is an error in the Terraform configuration, the plan step will fail, preventing any potentially destructive actions from being taken by the apply step. This acts as a safety check. Finally, add the step to apply the Terraform configuration. Proceed to line 44, press the backspace key once, then type --name: Terraform apply. Press enter, type 2 spaces, run : Terraform apply auto approve. This command applies the changes required to reach the desired state of the configuration. The auto-approve flag bypasses interactive approval of the plan before applying, which is necessary for automated workflows. Each of these steps is critical in the lifecycle of Terraform management within CI/CD. They ensure that your infrastructure as code is correctly formatted, validated, planned, and then applied to your environment. The steps are run in sequence, each one depending on the success of the previous step to proceed. After carefully following each step and inputting the code, your workflow should now be fully configured and ready for action. For your convenience and to cross-check your work, a reference link to the deploy website.yaml file is provided in the video description below. Now save the file, and in the next task you will commit it to your repository to start using the GitHub Actions workflow. You will now test the GitHub Actions workflow you've just set up. To do this, you will need to commit and push your workflow to GitHub. Open your terminal, and navigate to the root directory of your local Git repository. You can confirm you are in the root directory by running the pwd command. Stage all modified files for commit by running the git add command. In the terminal, enter git add. This command adds all the changes in your project directory to the staging area, including the workflow file. Commit the staged changes to your local repository with a descriptive message. In the terminal, enter git commit -m implemented deployment workflow . Finally, push the commit to the main branch on your remote GitHub repository. The push to main will automatically initiate the workflow as it is specified under the on key in your YAML file. In the terminal, enter git push. Go to your GitHub repository in your web browser, and click on the Actions tab. You should see your workflow listed there. The workflow should start running automatically after your recent push. You will see it as an in-progress run. Click on the workflow run to see detailed information about each step's execution. Monitor the progress of each job and step in real time. The workflow should run successfully without any errors. If your workflow doesn't execute as expected, return to your code or workflow file to make adjustments. Congratulations, you have securely automated your infrastructure deployment through GitHub Actions and Terraform, with a focus on best practices such as using GitHub Secrets for sensitive information.